You're welcome to Dynamic Educational Hub channel. Your answer to the very question. If you are just watching my video for the first time, kindly subscribe to my channel and click on the notification icon to get notified when I release new videos like this. What are we learning in this video? This is a continuation of the previous video, which is inverse of matrix. So I want to prove the inverse of matrix. I want to prove the formula. How do we get this formula? How do we get 1 over determinant multiplied by adjoint of matrix? Without wasting time, let's start proving. So let me give you a background knowledge. Now the first thing we need to know is we need to understand a unit matrix. In my first video on matrix, I've explained unit matrix. Now we have unit matrix of order 2 by 2, unit matrix of order 3 by 3, unit matrix of order 4 by 4. Now inverse is also known as multiplicative inverse or reciprocal. From the knowledge of algebra, inverse simply means multiplicative inverse or reciprocal. There's another inverse which is additive inverse. So we are not talking about additive inverse here. Now if you find the inverse of any number, it means you are raising the power of that number by -1, -1. So inverse of 2 is going to be 2 raised to the power -1. Using indices, 2 raised to the power -1 is going to be 1 over 2. Now when you multiply a number with its inverse, what are you getting? 2 multiplied by 2 raised to the power -1, the inverse of 2. So we are going to get 1. This is the basics of our proving derivation. Now which means that if you have a matrix, when you multiply it with its inverse, you are going to get a unit matrix. So A multiplied by A inverse is going to get 1. So the same thing for a matrix A of order I by I, when you multiply it by the inverse of that same matrix, which is also going to be of order I by I, you are going to get a unit matrix of order I by I. So this is the foundation of our proving and derivation. So we want to use 2 by 2 square matrix, which is the simplest form of square matrix, to find this derivation, to do this derivation. To do that, let's have our matrix which has an element A, B, C, D. Now let the inverse be another matrix which is having different elements, which is I, J, K, L. So what we want to do here is to derive a formula in which our derivation will just have this element of a element of this square matrix. So what did I mean? So if you multiply the two together, you multiply this matrix by its inverse, which is this. So we are going to get what? A unit matrix of what? Order 2 by 2. So if you are using 3 by 3 for our derivation, we are going to get a unit matrix of 3 by 3. So for 2 by 2, we are getting this, isn't it? So this is the foundation of our derivation and proving. So we want to use this to prove our formula. Let's have A, B, C, D, this matrix multiplied by the inverse, which is I, J, K, L. We don't know it. So you just want to relate them together. So when you multiply them together, what are you going to get? Using vector multiplication, do that, you are going to get AI plus BK. For that, you are going to get AJ plus BL. For the second row, you are going to get CI plus DK, then CJ plus DL. So this is the multiplication when you multiply the two together. And what are you going to get? We are going to get a unit matrix. Now we can relate them together. We compare them. So this one is going to this one, equals to this. So this is going to equals to this, and this is going to equals to this, and this is going to be equals to this. So let's call it equation. This one is equation 1, equation 2, equation 3, and equation 4. So we want to solve this equation by relating them together. So we want to find the value of I, J, K, L in terms of A, B, C, D. That is what we want to do. Now to solve this, we have 4 sets of linear equation to deal with. Now from equation 3, let's start with equation 3. this equation, since we want to make I, J, K, L, we want to find the value of I, J, K, L in terms of A, B, C, D. So it is proper for us to always make any one of them solve a formula. So from equation 3, we can rearrange equation 3 and make K solve a formula. When you rearrange equation 3, this equation, so try to make K solve a formula. To do that, you transform this to the other side. So that is why we have this dk is equals to minus ci. Divide both sides by d. To make K solve the formula, you have K is equals to minus ci over d. Now, we can substitute the value of K into equation 1. So this, let's substitute it into equation 1. Substituting it in equation 1, what are we going to get? Where we see K, we can put what? Minus ci over d. Now, for equation 1, we have ai plus b K, this is our K, C minus ci over d, and it's equivalent to what? Is equals to 1. So if you expand this, you are going to get ai plus minus bci over d is equals to 1. So you use this b to multiply this, get this. In order to get rid of this denominator, we can multiply both sides. From the concept of equation, whatever you do to the right hand side, you do to the left hand side. So we want to multiply the two sides, we want to multiply it by d to get rid of this d. So multiplying this side by d, you also multiply this side by d. So let's expand that. To do that, dA, when you multiply this one by this, you get this ADI minus, when you multiply d with this, don't forget this plus and minus, that is why we have minus. D, we cancel d here, so you are left with what? Minus BCI. 1 multiplied by d is equals to d. Don't forget the goal. We are making IJKL, putting them in terms of A, B, C, D. So we are left with I here. Now the next thing is, we can factorize this guy. Bring out your I. So you are left with AD minus BC is equals to D. So you divide both sides by what? By AD minus BC. So when you divide both sides by AD minus BC, what are we going to have? I is equals to D by AD minus BC. So you have related the terms of, you have related I in terms of A, B, C, D. So this is I. Since you have gotten the value of I, we can put it here to get the value of K in terms of A, B, C, D. So using equation 1, don't forget that our equation 1 is what led to this. So you want to substitute for I. So just put the value of I here. Now to do that, we have K is equals to minus C. This one is I. What is the value of I here? Here. D over divided by D, that is the meaning, divided by D. When you expand it, what are you going to get? Let's expand this. That is what we have done here. We substitute for I here. So that is, K is going to be what? Minus C D over AD minus BC. Division means you change it to multiplication by doing the reciprocal. So times 1 over D. So 1 multiplied by minus CD, you get minus CD, and this D will cancel this D. That's why you are left with minus C. So you are left with AD minus BC. So K is equals to what? Minus C over AD minus BC. The first thing, I is this, and K is this. So we have related, we have found the value of I and K. The next thing is to find the value of J and L. To do that as well, have this cleaned up. To do that, we have used equation 1 and 3. Now we are going to use 2 and 4. From equation 2, this is our equation 2. Equation 2 is right here. Now let's try and make J solve the formula. To do that, you are going to bring this BL to the other side. So that is why we have AJ is equals to minus BL here. Then you divide both sides by A to make J solve the formula. Don't forget the goal. A, B, I, J, K, L in terms of A, B, C, D. So J is equals to minus BL over A. Is that correct? And the next thing to do here is we substitute for J in equation 4. Just put this and dump it in equation 4. So just dump it. To do that, this is equation 4. Where we see j, we put minus bl over a. Now you have c, you have your j, which is minus bl over a plus bl is equals to 1. Now expand that. When you expand that, you get minus bcl over a plus dl is equals to 1. Next thing to do is multiply both sides by a. So you have a multiplied by the left hand side, then right hand side multiplied by a. So if you expand that, a will cancel a, you have minus bcl plus adl is equals to 1 multiplied by a. What is the next thing? We have L here, so factorize, bring out your L. L outside, you are left with what? Minus BC plus AD is equals to A. Divide both sides by minus BC plus AD. So when you divide both sides by minus BC plus AD, you are going to get L is equals to A over minus BC plus AD. Rearrange this. So AD coming first, then you have minus BC. So that is what we have here, A over AD minus BC. So we've gotten the value of our L, which is this, A over AD minus BC. The next thing is we will substitute for the value of L in this equation from equation 2. This equation 2, we already solved the value of J. So let's just put the value of L here to get our answer. To do that, using equation 2 substitute for L. That is what we've done here. J is equals to minus BL. This is minus BL over A. So we are going to get minus, what is our L? L is A over AD minus BC. So that is why we have what? Minus A over AD minus BC multiplied by B. This is L. L can come first. That is why we have it here. Multiplied by 1 over A. This A here means divided by A, which is 1 over A. So we have 1 over A here. This is our L here minus B here. L is A over AD minus BC. So when you solve that, A will cancel A. You are left with minus B over AD minus BC. So J is minus B over AD minus BC. Then you have it here. So here we have the value of I, J, K, L in terms of A, B, C, D. So which means I is this, J is this, K is this, and L is this. So I is this, J, K, and L. Check this very well. You see that there is something common to them. So let's bring that particular thing outside. When you factorize this, when you just try to bring out your D here, you are left with 1 over AD minus BC. Bring out your minus B, you are left with 1 over AD minus BC. Bring out your minus C, 1 over AD minus BC. Bring out your A, 1 over AD minus BC. So is that clear? This one is straightforward. Next thing is, there is something common here. D is being multiplied by this, minus B is being multiplied by this, minus C is being multiplied by this. So we can bring it out from the knowledge of scalar multiplication. So bring it outside, just like factorizing. You bring it outside, you get this. Now look at this formula very well. Don't forget, for 2 by 2, AD minus BC is what? Determinant. And this, we have it here from my previous video, determinant of matrix. It is what? AD minus BC. So you have it here. We can also see from this video, from my explanation adjoint of matrix, is that adjoint of this matrix, of any matrix in this format, is what? D minus B minus C A. And what do we have here? D minus B minus C A. So which means that the inverse of this square matrix is 1 over determinant of matrix multiplied by the adjoint of the matrix. Using 3 by 3 is going to take a lot of time. It's going to take much time. You will still arrive at this And if you want to solve it using 3 by 3 matrix, you must be very careful. I've solved it. You must be very careful. You will still get the same thing. And we have proven that the inverse of a matrix is 1 over determinant of matrix multiplied by adjoint of matrix. And let's look at the criteria for matrix to be invertible. That is, the criteria for a matrix to have an inverse. The first criteria is it must be a square matrix. And the second criteria is it must be a non-singular matrix, which means that its determinant must not be 0. So for any matrix to have inverse, that is, for a matrix to be invertible, the first condition is it must be a square matrix, and the other condition is it must have a determinant that is not equals to 0. So if you are solving any question and you are asked to find the inverse of that matrix, the first thing you need to check is that matrix a square matrix? After you have checked for that matrix, that is, that matrix is a square matrix, the next thing is to find its determinant. Once the determinant is 0, that matrix is not going to have inverse. But if the determinant is not 0, you can find the inverse of that matrix. Here is a simple example on 3 by 3. So let's see how to find the inverse of this 3 by 3 matrix. To find the inverse, the first thing is to find the determinant of this. And from my previous video, solve this. In my previous video, determinants, I've solved this. And if you find the determinants, we are getting 119. The same question, I've solved the adjoint. So the adjoint is this as well. Determinant is. So let's plug in our value. Don't forget that inverse of a matrix is 1 over determinant of a matrix multiplied by the adjoint, multiplied by adjoint. So inverse of this is going to be 1 over 119 multiplied by the adjoint. So when you do the scalar multiplication, you are going to get this. This multiplied by 9, you get this. This multiplied by 27, you get this. And this multiplied by minus 2, you get this. This multiplied by minus 44, you get this. This multiplied by minus 13, you get this. And this multiplied by 35, you get this. This multiplied by minus 8 over 119, you get this. This multiplied by minus 8, you get this. This multiplied. So that's how to solve inverse of matrix. For 3 by 3, it's going to take time because you have to find your minor. Find the minor, you find the cofactor. After cofactor, you find the adjoint. Then you can find your determinant. Then you plug in those values inside your formula. Inverse 1 over determinant multiplied by adjoint. And here is a simple exercise, which is find the inverse of the matrix above. Find the inverse of this matrix and solve it. Comment in the comment section your view about this video, and if you actually solve this question. Like my video, share my video, and comment. My next video is going to be an interesting video, which is Gaussian elimination method of solving set of linear equation, simultaneous equation. Thanks for watching my video up to this moment. See you in the next video. Bye for now.